This next lesson is about interval notation. And interval notation is a common method of expressing the solution of an inequality or the domain and range of a function. For example, if I have the equation x minus 4 is less than 3. It's a fairly simple inequality to solve. All I need to do is add 4 to both sides. And that cancels out this negative 4, so I come up with x is less than 7. And the graph of this can be put onto a number line. And the value 7, I'm going to plot with an open circle because it's not included in the set, because I'm just looking at the values that are less than 7 and not less than or equal to. And I'm going to shade this set to the left because I want all the values that are less than 7, not greater than. To the right would be greater than. Now, this set on the number line looks like it stops at negative 10 and positive 10, but it actually continues on all the way to negative infinity and positive infinity in each direction. So when I write the solution in what's called interval notation, I'm going to use the negative infinity as my lower end point and the 7 as my upper end point. Now, another thing that's used in interval notation is instead of using open circles, for instance, if I took this away, I could use a parentheses to represent excluding the point. Either way, it doesn't make a whole lot of difference. Generally, you will see on graphs the parentheses used as opposed to the open and closed circle, but you'll also see the open and closed circle used in two-dimensional graphs. So it really doesn't make a difference on your graphs which one you're using, as long as you understand both notations. But the interval notation looks like this. Interval notation is a set of values that starts with a lower end point and goes to an upper end point. The lower end point here is negative infinity, and the 7 is my upper end point, because that's where I stop, and I'm using a parentheses to represent exclusion. A few notes about interval notation. First, parentheses represent exclusion, similar to an open circle. And its parentheses are used with the less than or greater than symbols, but also anytime you're using positive or negative infinity. You always put parentheses around those values because they're not actual numbers, they're just concepts. Next, brackets represent inclusion, similar to a closed circle. And these are going to be used when you have less than or equal to or greater than or equal to in an equation. So let's look at some different cases of interval notation so that you can kind of get an idea of the different ways to express inequalities. So the first one, which we just saw, x is less than a. So a is just some number, on a number line. So let me plot that. It doesn't matter exactly where. So here's a. If x is less than a, then we're not including the a, so I can use an open circle, or I could use a parentheses. It really doesn't make any difference. If you use a parentheses, you want to point it in the direction of the way you're going to be shading. So I would shade this direction, because I want the values that are less than a. And remember, this goes all the way down to negative infinity, and this direction I go all the way to positive infinity. So this set represented in interval notation starts with negative infinity and goes up to a. And remember, your first value you put is always a lower bound, and the second value you put is always an upper bound. And therefore, these sets always have to be ordered from the smallest number to the largest number. All right, let's say we have x is greater than a. So I'll put a, some number, on this graph, and I'm going to be shading to the right this time, so I'm going to put a parentheses and go to the right. And I'll be going to positive infinity this time. So in interval notation, this will look like a comma positive infinity. And you don't have to write the positive in front of that. It's understood. Okay, our next case, x is less than or equal to a. Right, if I just put a on my number line here. Now this is similar to my first case, except for it's less than or equal to instead of just less than. Because it's less than or equal to, I use a bracket instead of a parentheses. And so, since it's less than, I'm going to be shading to the left. Remember, this goes all the way to negative infinity. So my interval notation is going to look like the set negative infinity, comma a, and then a bracket instead of a parentheses. But notice, still, there's a parentheses around the infinity symbol. That's always the case. Lastly, x is greater than or equal to a. So let me put a on this graph. If it's greater than or equal to, I'm going to shade to the right. And this is going to go to positive infinity. So my interval notation starts with a with a bracket and goes to positive infinity. And again, you can put a plus in front of that, or you can leave it off. It doesn't really make any difference. So it's understood if you leave it off. Now let's look at some cases that do not include infinity. So for instance, this set right here, where x is greater than a and less than b. This is kind of a notation that we use to simplify the concept of between in mathematics, because the way you read this is x is greater than a and x is less than b, is how you read that. But it's a little bit more compact in this form. So on a graph, I would need two numbers, a and b. And I'm looking at all the numbers in between them. So I'm going to shade in between. And I'm not including either endpoint value. So I'm using parentheses around each. So the interval notation here would just be the interval from a to b, parentheses around each. Which, it's kind of unfortunate that this ends up looking like a coordinate pair. Sometimes it's hard to determine if you're being given an interval or you're given an ordered pair. But generally it's understood through context which is which. But that is kind of an unfortunate thing here. The next case, where x is greater than a and less than or equal to b, well, I'm still looking at all the values between a and b, but they have to be greater than a, so a parentheses on the left-hand side, less than or equal to b, so a bracket on this right endpoint. So my interval notation would look like this. Next up, similar situation, it's just now the bracket's going to be on the lower end point because it's greater than or equal to a, less than b, and then shade in between. And the last case is just greater than or equal to a, less than or equal to b, and so you've probably guessed here, both endpoints get a bracket. And so the interval notation would look like this. All right, now you may run into situations where you have multiple intervals. So what you would do there, like in this case, where x does not equal a, it's a little bit different. So let's say we have the value a. So I want all the values that are not equal to a. So the values greater than a would not be equal to them. All right, notice I put a parentheses on that set because I'm not including a. I don't want to include the a. But also all the values that are less than a, but also not including. So this looks a little strange with the double parentheses here. But if you think about it, I could actually change this to, say, an open circle. Okay? And then at that point, I have an open circle, so the only point that's not included is the value a. And I'm going to change that back to the parentheses because you'll probably see the parentheses in this class more than the circles. All right, now to express this in interval notation, you have to do two separate intervals. One that's going from negative infinity to a, so negative infinity to a, and then another set that's going from a to positive infinity. Now, anytime you have two sets of numbers that you want to join together, you use this symbol here, which represents union. So union of two sets means to take all the values in the first set and combine them with the values in the second set. I've seen students want to put like a comma in between, and I understand what you're trying to represent there, but the correct answer to join two sets together is to use a union symbol. Next up is a situation like this, where I have here what's called set builder notation. And with set builder notation, you're basically trying to describe the elements of the set. And the way you read this is, for all values of x, so for all x, and this parentheses is read such that, and then your cases are after that. I'm sorry, I think I said parentheses, force of habit in this video. The colon. After the colon, you're describing the points that are in the set. So this would be all the values of x such that x is less than or equal to a or greater than b. So let's look at that. So if I have a and b here, so all the values that are less than or equal to a, so less than or equal to a would be this set of values here, going all the way to negative infinity, or greater than b. So that would be this set of values. So my interval notation is going to look like the set going from negative infinity to a, including the a, union b to positive infinity. So I'm taking two sets of values and joining them together. Now, the last situation we're going to look at here, again, I have set builder notation, but it's all the values of x such that x does not equal a and x does not equal b. So I have all the values except for a and b. In order to make that happen, I basically am going to do the same thing that I did in this first situation. So two sets, kind of just skipping the values a and b, but it'll look like this. So to skip all the values from a, I'm looking for everything less than that. So from negative infinity to a. And then all the values between a and b, and then all the values greater than b. So I end up actually writing three sets here. So in interval notation, this is negative infinity to a with a parentheses, union, a to b with a parentheses, union, b to positive infinity. And I've had students in the past ask, why can't I just simplify this down to just negative infinity, comma, positive infinity, which is the same thing as all real numbers? Well, the problem is this set right here includes the values a and b. But the problem is, I want a set that does not include those values. And so this is the way of expressing a set that has all the values from negative infinity to positive infinity, but not a or b.